This case, in this one, we actually need to use a little bit different type of knowledge. So we don't have a triangular prism in our formula sheet, in our reference sheet. But this is something that could come up. So we need to be able to adapt. We need to figure out what it is that's going to make it so we can still solve this problem. So what we need to kind of know is that if we find the area, we can and that area stays constant in one dimension, then we could just multiply along that dimension. So what does that mean? So basically, look, this is a circle, let's say. I know the area for a circle, okay? The area for a circle that's given to us as pi r squared, where r is the radius, okay? That's the radius. This area along a cylinder stays the same as I go up the cylinder. So if I cut out the circle here, this area would be exactly the same as the original area on the floor, and it would be exactly the same as the area on the top. So the area is staying constant as I go up the height. So then that means that the volume of the entire cylinder is going to be that original area times the height. And that's exactly what happens, because the area is pi r squared. And then it's times h, and that's the volume of a cylinder. Okay, you could always multiply up that dimension. That's true of, look, if let's say I said a rectangular prism with a square base, right? So here's a square base, right? And then here's the rectangular prism going up. Let's say, I don't know, try my best. Here we go. Okay, right? And I have it that this square has some area at the base, right? The area is going to be, let's say that the side length is s, then the area is s squared, right? S times height. Length times width times height is the volume. The volume is going to be the area times the height, because as I go up this rectangular prism, that area for that square stays the same. So it's area times height, which is just s squared times h, which is indeed the volume of a rectangular prism with a square base. Base times width times height. Okay, now in this case, if you look at this face right here, okay, it's in the shape of a triangle, okay, and you multiply down along 5 to get the volume of a rectangular prism. So let's write down that first. So the volume of a rectangular prism is the area of the triangle times whatever you want to call this dimension. Let's say h. Okay, so the volume of this is going to be the area of a triangle, we should know, is 1/2 base times height, and I'll use a different letter for this. Let's say, I don't know, width, w, and this would be the volume of this figure, this rectangular, this triangular prism. Because look, this triangle has some area, and it fills up only one of these, but there's 5 of them as you go down. So it makes sense to say that the volume is 5 times that one area, right? Imagine 5 of these. This is 1, then this is another 2, 3, 4, 5, and then the whole prism is filled in by that area. So okay, so now if the volume of the prism, so they tell us that this is essentially, this volume is 160, is 1/2 base times height times width. And we know that the base is 8, so this becomes 4, because 4 times 1/2 is that. The height, I don't know what h is, but I do know that w is 5. One of the rectangle has a side length of 8 and a side length of 5. Good. Okay, what is the vertical height? Okay, so all we're looking for is essentially height, so this is great. So we're done after this. Once it is that you get over finding out what the volume of a triangular prism really is, this problem is fairly straightforward. 20 times h is equal to 160. And I get h is equal to 160 by 20, which is 8. And then this is my answer.